Swayam Prabha. Digital India. Educated India.
Hello everyone. Today I am going to deliver a lecture on thermit welding process. It is a thermochemical fusion welding process. This you just keep it in mind. Subsequently, I will discuss in details about this process. This is the content of today's lecture. That first of all I will discuss about history of this thermit welding process. Then I will discuss about introduction of this process, then I will discuss about principle of operation, then thermit welding mixtures. I will discuss about the steps followed in thermit welding process, that means procedure of thermit welding process. Then I will discuss about the advantage, disadvantage, its application, and at the end I will try to discuss about its safety precaution. So, in history, because why I am going to discuss about the history of this thermit welding process, because it has a very interesting history, that is why I am just discussing here. You see, this thermit welding techniques generally was discovered by Hans Goldsmith of Germany in 1896. Okay, that means in 1896, Hans Goldsmith of Germany discovered this thermit welding process. But what happens, he start about this process in 1893. So, he initially began to experiment with aluminothermic reaction. Aluminothermic reaction means it is a reaction process where generally aluminum is used as a elements. That is why what happens in this process, what happens, there is developed some huge amount of temperature. It is a exothermic reaction process, that is why it is called aluminothermic reaction process. Okay. So, he began to experiment with aluminothermic reaction process in 1893, and what happens, afterwards he did lot of research activities in this reaction related field, and finally he discovered this thermit welding process in 1896 by using this aluminothermic reaction process. Now, aluminothermic reaction generally is a exothermic process, which I have told you. That means exothermic process means due to this reaction process some heat is generated, that means it exert heat. Okay. That heat is utilized to melt as well as for melt the thermit composition, and what happens, it is also used to fuse the weld region and join the region. Okay. So, first of all you see, so aluminothermic reaction are highly exothermic process where generally a metallic oxide is used with aluminum powder. So, due to the large amount of heat released by exothermic chemical reaction, this process means get it popularity in the field of industry. That is why what happens, it start its application rapidly in the field of manufacturing industry. That is why this Goldsmith started a company on this thermit welding process. Just after discovering this process, after 1 year, he started a company in 1897. Just you see, after that this thermit welding process get its popularity in different manufacturing field. So, by the end of 19th century, the thermit process had been successfully used to make repair to large cast and forged steel part. Okay. This which I have written here. Now, in 1904, this Goldsmith Thermit company expanded in different country. It was expanded and it was founded in New York also, and its extensive use of thermit welding process on steel railway started in the USA. In 1904 itself, in US, it get its popularity in the field of railway section joining process. Okay. Afterwards, nowadays also it has lot of application in the field of railway application as well as in different cast products. Now, here I am going to discuss the brief introductory part of this process. It is in the category of what I have already told you, thermochemical fusion welding process. Why it is called thermochemical fusion welding process? Because in this process generally the heat is generated by some chemical reaction. Chemical reaction generally is developed by a mixture of aluminum and some metal oxides. Okay. Sometimes aluminum or sometimes magnesium also is used. As this process, in this process heat is generated by some chemical reaction, that is why it is called thermochemical, and by this process generally material goes beyond its melting point temperature. That is why what happens, this process is called fusion welding process, because due to fusion what happens, joining is taken place. This process generally involve a exothermic reaction, which I have already told you. Exothermic reaction means it release heat externally, you can say, that means it produce heat. Okay. That is why it is called exothermic reaction. You know about this thing very well. I am not going in details about this thing. This process is used to welding of heavy and large structures, which I have already told you. This process generally does not require any electrode as well as power supply. This process also is done with or without the application of pressure. That means in this process some application we have to use pressure, some application we need not to apply pressure. It is a process in which heat is produced for collisions is produced by superheated molten metal from the chemical reaction of thermit. Okay. This thermit, what is thermit? This I have written here. So, thermit is a mixture of aluminum and Fe3O4. It is a iron oxide. It sometimes is called generally it is called magnetite. Sometimes it is called ferric oxide. So, this generally it is this thermit mixture is a composition of powder of aluminum and Fe3O4. Okay, that produce a exothermic reaction when we ignited this mixture. Okay. So, due to this ignition of this mixture or due to this reaction, whatever the heat is generated at this heat, this mixture melted, and what happens due to this melted, whatever the metal converted to a liquid form, that metal is used to fill the gap, and that metal temperature also utilized to fuse the base material or parent material which we are going to join, and fusion welding is done. Okay. So, everything I will discuss in details in subsequent slide. So, the heat of this thermit welding may be utilized in two ways, which I have already told you. One is this heat we can directly use in fusion welding purpose without application of pressure, and this heat we can utilize for pressure welding purpose also, that I am just showing. So, this heat once we use for fusion welding purposes, here generally directly this heat is utilized to fuse the parent material, where generally no external pressure is required to use, that is called fusion welding process. And here this thermit reaction mixture, whatever the thermit reaction mixture after melting, whatever the molten metal is formed, this molten metal is used as a filler material also. Okay, that means it is deposited in the gap and its joining is taken place. Okay. And now in pressure welding, it may be heated. What happens, metal part side by side, here the temperature rise in such a range by this thermit mixture, whatever the temperature we are getting, that temperature we can utilize to raise the temperature of parent metal within a range of forging temperature. Forging temperature means, forging temperature is a temperature where material becomes soft enough, its plasticize. This temperature range is generally around 70% of melting point temperature of parent material. This you should keep it in mind. So, at that temperature generally this material becomes soft enough. So, once we apply some pressure, then what happens, we can join these two workpiece together. So, as in this process this material which we are going to join, that is not melted, that just there some softening temperature is rising, and what happens, and there only this temperature is sometimes is called forging temperature. So within that range, temperature range, the material becomes soft enough and some external pressure is applied over there. Due to this external pressure, generally joining is taken place in this plasticized material. Okay. As some pressure is applied here, that is why what happens, it is called pressure welding process. And this thermit welding reaction heat also sometime it is applied in brazing purpose also, and this thermit reaction generally involve aluminum. So why it is called aluminothermic reaction? Because in thermit reaction it involves aluminum, that is why what happens, this reaction process is also called as aluminothermic reaction process. Now principle of this operation, in this process there is used a very interesting types of what it is called idea, like this thermit welding is based on casting and foundry practice. So in casting and foundry practice, whatever the procedure generally we utilize, more or less similar procedure also we utilize in thermit welding process. How it is, I will explain here. Here generally by means of chemical reaction, a volume of generally molten material is generated by the reaction in thermit mixture, okay, which molten material generally we used to poured into the joint to be welded. Okay. This molten material act as a filler material, you can say, that means after thermit mixture reaction, whatever the material or molten material is formed, that act as a filler material here. Now here the heat is produced by highly exothermic reaction, which I have already told you. For this exothermic reaction, there is used a metal oxide. This metal oxide usually is a iron oxide, because this what it is called, this thermit welding process is popularly used especially for means what it is called iron related metal and its alloy. Okay. That is why what happens, it is mainly consists of a metal oxide and a metal reducing agent. That is called generally, that is mainly is aluminum. Sometimes this reducing agent can be magnesium. Now you should know why it is called reducing agent, because it is a donor of electron, you can say, and it is a high affinity to generally combine reaction with what it is called oxygen. That is why what happens, this is called reducing agent, because aluminum is a reducing agent. Why it is called reducing agent? Because it generally contribute, or you can say it donate the electron to electron, and what happens, it is oxidized by its own reaction. Okay. That means why it is called reducing agent, little bit I am explaining, because the reducing agent is an element or compound we can define like that, which losses an electron to an electron recipient, that is called oxidizing agent in a chemical reaction. So what we understood, a reducing agent generally is a donor of electron, we can say. Here aluminum generally is used as a reducing agent in this process. Now this aluminum has a very high affinity with oxygen. That is why this chemical affinity of aluminum for oxygen is the basis for thermit reaction process. Okay. Some of the thermit reaction process here I am showing. You can see generally this aluminum is used in most of the cases, you can observe there, and the oxide can be ferric oxide, ferroferric oxide, or sometimes copper oxide is also used. So once this mixture, so this combination of two composition, one is oxide of iron or copper and pure aluminum powder, this mixture is called thermit mixture. This you should keep it in mind. So once we generally ignited this mixture, this any of this mixture, it generally produce pure iron and aluminum oxide. You see this aluminum oxide, and its release some temperature, or if you release heat, this due to this heat the temperature rise of that mixture is around 3000 to 5000 degree centigrade, depending upon this mixture. Like if you use ferric oxide, in first equation I have shown here, due to this ferric oxide we will get a heat energy which is around 181.5 kilocalorie, which produce the mixture temperature or molten material temperature around 2960 degree centigrade. Once we just react it with ferroferric oxide, or you can say magnetite oxide or magnetite material with aluminum, then it produces a temperature which is around, you can see, which is around 3000 degree centigrade. Now, once we make it by using copper oxide, then what happens, copper oxide with aluminum reaction produce a temperature which is around 4865 degree centigrade, that means 4865 degree centigrade temperature. But here one thing you should keep it in mind, the serial number 2, that means this magnetite with aluminum mixture, this thermit mixture is popularly used in most of the application. But this serial number 3, this copper oxide also have a application in the field of electrical industry, that I will show you in subsequent slide in details. Okay. So, here just I have shown a diagram where generally this welding is done. This is one base material, one workpiece, this is another workpiece. So, in this region we want to make the welding. So, here you see, so this welding is done first of this thermit mixture generally ignited in this chamber. That I will also discuss in subsequent slide in detail. So, after that, once this molten metal form, this molten metal generally pass through a channel and it is deposited in this region. After that, what happens, it join together. Okay. So, how it is, every steps and its procedure details I will explain in subsequent slide. Now, this whatever the thermionic reaction I have shown you, this serial number 2 have a wide application. That means ferroferric oxide with aluminum mixture. This thermit mixture have a wide application and it's rise a temperature which is around 3088 degree centigrade temperature. But what happens, due to some loss in the chamber where this reaction happen, apart from this thing, due to some losses of radiation as well as convection related problem, what happens, some heat is losses. Due to this, what happens, its temperature reduced to around 2538 degree centigrade temperature. Then it is also further reduced due to the addition of other chemical composition of metal and the slag for fluidity purpose. Ultimately, its temperature reduced to a temperature of around 2100 degree centigrade. This you should keep it in mind. Though here the temperature rise due to actual reaction is more than 3000 degree centigrade, but what happens when it is pour to what it is called welding region, or you can in joint region, there the temperature goes around 2100 degree centigrade. Why? Because there is occur different types of losses. So, here we can find out some efficiency also, that means what is the thermal efficiency of this process, that we can find out by this loss itself. Here one thing you should keep in mind, thermit reaction is non-explosive reaction, it is not an explosive reaction. Though here this huge amount of heat is generated, but you may think whether it is a explosive or not. No, it is not explosive, it is a non-explosive reaction. That is why here I have written this thing. Now, this thermit mixture generally ignited by using a low ignited temperature powder. Generally that powder is called barium peroxide. A small proportion of barium peroxide mixed with this mixture. Once we ignited inside this mixture by using some magnesium ribbon, then or with some masses, then what happens, these things ignite very easily. That is why this a small proportion of barium peroxide also sometimes used inside this mixture to help the ignition. Okay. Now, here one thing you should keep it in mind, what should be the proportion of this two mixture in weight percentage, that also you should know. It is observed that for maximum efficiency, the magnetite thermit mixture means magnetite also this Fe3O4 ferroferric oxide also called magnetite. That is why here I have written this magnetite thermit mixture should contain 23.7% aluminum and 76.3% iron oxide in mass percentage. This is the mass percentage, you should keep it in mind, because if it is 100 kg mixture, then 76.3 kg should be this Fe3O4 mixture powder, and 23.7 kg should be aluminum powder. Okay, this you should keep it in mind. Now, what are the different types of thermit mixture generally we use, that we should know. Actually, there can be different types of thermit mixture. Here I am showing 5 different thermit mixtures which are popularly used in thermit welding process. One is called plain thermit mixture. It is a mixture of iron oxide and finely divided or finely powdered form of aluminum. Okay. It is the basis of most thermit mixture, and it produces one of the highest temperature of thermit welding process. One of the highest temperature means because copper oxide also have produced a very high temperature, that is around 4000 degrees centigrade. Here is also one of the, that is why I have written one of the highest temperature, that means 3088 degrees centigrade generally here it is produced. So, this plain thermit is generally is the mixture of iron oxide and its finely divided aluminum. Then mild steel thermit. Here with this plain thermit mixture, here we added some mild steel which is punching to increase the metal product. Okay, that is why some mild steel powder also generally punching inside this mixture. Okay. Due to this, what happens, it increase the metal product. Carbon and manganese are also added to balance the reaction in mild steel thermit mixture. Then thermit mixture which is widely used for railway joining purpose, that is called thermit for welding rail. It is also consist of this plain thermit, that means in most of the cases this plain mixture is there, that means magnetite plus aluminum powder. Apart from this thing, there is used some other composition, like what happens in thermit for railway, there is used this carbon and manganese which is used to adjust the hardness of the deposited metal. Okay. Because if we use this carbon and manganese with this plain thermit mixture, it generally used in such a proportion, so that this hardness of this deposited metal should be balanced with the hardness of the railway being welded. Okay. That is why this mixture is especially designed for welding of rails. Then cast iron mixture also, that means cast iron thermit mixture, it is a plain thermit with addition of, here you see, ferrosilicon and mild steel punching. This you should keep it in mind. So, here use some ferrosilicon. So, once you use this ferrosilicon, then what happens, its property become very hard types of things, you can say, that means it produce a cast types of product. So, what happens here, unless the weld area is post heat treated, this weld metal is generally not machinable. So, due to this ferrosilicon and mild steel punching with this plain thermit mixture, it generally is become so hardened types of material, so that it is not easy to machinable until we do the post heat treatment operation. Okay. So, after making the product, we have to do some heat treatment, then what happens, its property changes, after that we have to do the machining operation. Now, thermit for welding electric connection, what I have already told you, here generally copper oxide and aluminum is used. So, this thermit for welding aluminum connection, this thermit mixture actually contain copper oxide and aluminum powder. This which I have shown in serial number 3 equation, that you can observe in my previous slide. Now, what are the procedure involved in thermit welding process, that we should know. Here you see there are around 8 different steps we used to follow in thermit welding process. This is the thermit welding setup, you can see. This is the railway cross section which we want to join together. Okay, which I want to join together. You can see this is the side view, or you can say of this section. So, in this section generally there is required to do different types of operation. What is this different types of operation, that I will show you in subsequent slide. So, to do the welding in this section, we have to follow different types of step. That means, this is one workpiece and this is another workpiece. Okay. So, this is here we want to do the welding. Let us here we want to do the welding. So, for that what are the thing required to do? Now, we know this rail section, if we just look from this side, then we can get the railway section, which is generally look like this, correct, which is generally look like this. So, this section here I am showing in left side. Now, you see in this section we want to do the welding, in this section we want to do the welding. So, what are the things required to do? We have to do different types of operation before going to do welding here. Okay. Like what happens, first of all we have to clean this surface we have to clean properly. Then what happens, we have to provide some gap in between these two rail. Okay. This provides some gap in between two rail. So, for this cleaning should be such there should not be no grease, no dust. Okay. It should be sharply cleaned. This operation in cleaning purpose generally we sometimes use short pinning types of operation. Sometimes also we use what happens by some torch heating also we can clean that surface. After that generally there is used allowance for contraction. So, this allowance for contraction generally we used to provide a gap in between these two workpiece, which is varying around 0.6 millimeter to around 6 millimeter, or sometimes some book it is written 1.5 mm to 6 mm. Okay. So, this much of gap generally we used to follow, we used to provide in between this gap, because it generally depend on the size of the what it is called size of the section. So, if the section size is high, then what happens, there is a chance of more contraction of this molten material as well as workpiece material. So, their gap should be higher side. If the size of this workpiece, or you can say thickness of this workpiece is less, then there will be less gap, because what happens, once we pour the molten material in this region, then once it cool, at that time generally there is occurred some what it is called contraction. So, due to this contraction, if the gap will not be there, then what happens, there can be distorted types of weld. That is why to balance these things there is required to provide some gap in between. That is why here I have written allow for contraction. Then construction of mold. So, after that generally we have to make the mold. So, after cleaning and providing this gap, we have to make a mold around this joint. Okay. So, this is the mold. So, mold sometimes written as MOULD, or sometimes it is written as MOLD also. Okay. This you should keep it in mind. So, this mold is made up from generally either by using green sand, or sometimes it is used by using some graphite types of material. Generally green sand mold which is used, that is temporary mold, that means it is a use and throw types of mold, but once we use graphite types of mold, it is a permanent mold, that means repeatedly we can use these things. So, around these things we have to make a mold. This is the sand mold I have shown here. So, around the cross section I have made this mold. Now, you see in this mold generally we have to provide some pouring gate. You see this is called pouring gate, through which then this molten material will pass and it deposited around this section. This is called pouring gate, and to generally evolve, or you can to remove the gases from this zone, there is required to use a riser. So, this is riser, and what happens at the top of the mold, generally whatever the slag is formed, slag means some impurity or some other what it is called flux composition. When it is this impurity and flux composition burn, then it is converted to slag. That slag have a weight lesser than this molten material, that is why it is float over the top surface of the molten material. So, that is why what happens, there is used to provide some slag basin. Once it coming from this molten material, from there can be some slag mixture also, and from this section zone also there can be developed some slag also, that generally float over this surface, that is called slag basin. Okay. There generally slag is deposited. Before going to do actual welding, first of all we have to make the mold. So, in this mold, first of all we have to make a pattern of wax pattern. We have to make a wax pattern in this zone. In this zone we have to make a wax pattern first of all. So, after making this wax pattern, what happens? After making this wax pattern, we have to make this mold around this wax pattern. You see, this is the wax pattern, this is the wax pattern cross section, wax pattern cross section. And why it is required to make? Because once we after that what happens, we have to provide the sand mold around. So if we just before making this wax pattern here, if we generally make this sand mold, then this sand also inserted inside this region, correct? So because we have to make a cavity where we want to make the what is called where we want to make the joining, correct? To make the cavity, generally first of all we have to make say wax pattern there. After that okay, we have to remove this wax pattern by heating. That how it is done I will show you. Okay, so first of all we have to make a wax pattern there. After that we have to insert this mold around. So you see, after this contraction allowance, we have to construct the mold. So mold, so in this mold there should be a wax pattern. This wax pattern is developed by using some wax. So this wax is heated to its molten state. After that it's pouring here, and what happens, this wax create a shape which is similar to the joining cross section. That means joining cross section. Clear? So after that, what are the things required to do? We have to preheat. That means preheating this mold, and we have to remove this what it's called wax pattern from this sand mold, because we have to make a cavity over there, correct? So to do these things, there is required a preheating gate. Through this preheating gate, generally a torch is used. This torch generally supply the heat in this cavity zone. In this cavity zone, here you see, in this cavity zone where this wax pattern is there. So due to this torch heating, this wax pattern will melted, and what happens? That section will form. That means mold cavity will form. So one mold cavity will form. After that also there is required something that is called preheating of mold. That means then once this mold cavity form, then we have to preheat that joining section within a range of some temperature, which is this temperature is around red hot temperature of this material or of this section. This temperature range is within a range of around 900 to 1000 degree centigrade temperature. So within this temperature, once we heat this joining section to two part of this material, then what happens? After that we generally pour this thermit reaction molten material through this pouring gate, and what happens? The material is deposited inside the section, and after that we have to opening the mold. This mold we have to open, this sand mold we have to open, and finally we have to finishing the weld. So these are the different types of steps we used to follow in this thermit welding process. That related thing I will discuss in subsequent slide in details how it is. So first of all, cleaning the joint. Second one is allow for contraction, then construction of mold, then preheat the mold, then crucible and its charging. This is also called crucible. This is this vessel which contain this thermit mixture, it is called crucible. Here generally this thermit reaction is done. How it is done, little bit I will explain in subsequent slide. Here you see, generally here the thermit mixture is added first. So after that, with this thermit mixture we used to add some barium peroxide which has a low ignition temperature. So after that we used a igniter. By using this igniter, this is actually a, you can say, magnesium ribbon types of things. So once we use this igniter, once we ignite this mixture, then what happens? Here is occur a chemical reaction. Due to this chemical reaction, huge heat is generated. At this heat, generally this mixture melting is taken place. So once this mixture melting is taken place, because in this mixture we observe there is developed iron plus aluminum oxide. This aluminum oxide generally its density is lesser than iron molten material. That's why this aluminum oxide float over the surface of this molten material, and then this molten material deposited just below this layer of what is called aluminum oxide. This molten material generally pass through a channel, you see this pass through a channel, and what happens, it poured through this pouring gate in this mold, and it deposited in this section. So, once we deposit it in this section, then what happens, this molten material get a shape of that section. So, once it solidify, then it form the joining. Okay. These are the different steps, only here it is given. So, one by one also I will discuss about this thermit welding procedure details in subsequent slide. So, first of all cleaning the joint. So, here joining to be welded should be cleaned and free from dust, which I have already told you. And what happens here, generally dust, grease, loose oxides etc. should be removed before joining operation. And this cleaning also required to do around 125 to 150 millimeter back from the end to be welded, must be cleaned thoroughly because this surface should be bright and any types of dust free, or you can say grease free region. Okay. Now, you see the adjacent end may be cleaned by sand blasting, or also there is used some oxyacetylene torch for surface cleaning purpose. Then allow for contraction, was I have already told you, depending upon the size of the part, this contraction space is within a range of 1.5 to 6 millimeter. Okay. Now, here also I have written that this contraction is provided because what happens, due to cooling of this thermit steel and also shrinkage of this base material, this allowance is provided, that means this gap is provided. So, this already I have shown in previous slide also details of this thermit welding process. So, now construction of mold. So, for construction of mold, generally after the part have been cleaned and spaced properly, that means allowing the gap, the next stage is the making of wax pattern. Then next step is making a wax pattern, which I have already told you. This wax pattern generally make by using molten wax. So, a mold is the part in which generally this metal part to be joined lies and molten metal is poured in it. Now that the wax is first placed in a container and it is heated until it reaches its plastic state, then this wax is then shaped around the part that are being welded together. Here you see this wax is generally, so this is a wax pattern initially we have to make. After that we have to make a hole or vent is made in this wax itself, because in this wax we have to make some vent or hole, because once we melt this wax, at that time this whatever the gas will develop, that gas should escape out from there. That is why a hole or vent is made in this wax from the heating gate to riser to enable gases to escape when the welding is begun. That means, this is the heating gate to the riser, there is required to make a hole or vent in this wax pattern. Okay. Then the mold should be provided necessary pouring gate, heating gate and riser. So, in this mold also there is required riser, pouring gate, heating gate, okay, slug basin. In this mold we should provide everything. So, I am not going in details how to make the mold. Okay. So, I have already told you this mold can be two types, one is can be sand mold, another can be graphite mold. Sand mold is temporary mold and graphite mold is permanent types of mold which you can reuse. Then preheating the mold. This preheating the mold is required because what are the wax pattern we make, first of all this wax pattern we have to remove from there. That is why preheating the mold by using a torch which is generally placed at the bottom side, you can say, or at the side of this mold. From here this torch is used to preheat this wax. So, mold is preheated to remove wax pattern, thereby leaving a mold cavity. So, once we remove this wax pattern here we will create a cavity. So, this cavity shape will be the section of this railway, that is this cavity, then whatever the cavity will form, once we remove the wax pattern, this cavity shape will be like this, if it is a railway section. If it is other section, then it will shape like that section. Okay, this you should keep it in mind. So, after that we have to dry the mold thoroughly this mold, whatever the mold cavity is formed, we have to dry that region, because if there will be any moisture types of thing, then what happens, there can be develop some steam, and that steam can porous that weld region, because this steam can entrapped in this molten material, and your weld quality will be porous type. That is why what happens, this mold region, after removing the wax, we have to bring a temperature to heat that region within a range of around 816 degree to 982 degree centigrade temperature. That means bring the part to be welded at a desired temperature. Once we make this temperature in this weld region, then what happens, there is a chance to prevent the chilling of the hot thermit metal, because if the hot thermit metal suddenly placed in a cool position, there is a chance of chilling of this mixture, chilling of this molten material. So, to prevent this section we have to heat to a sufficiently high temperature. That temperature range is around 860 degree to 982 degree centigrade temperature. Okay. The most common of preheating the mold is either by burning some fuel air mixture, or here we can use some other fuel also, like fuel can be propane, natural gas, or kerosene oil, or gasoline types of mixture. This mixture we use by the stores to preheat this mold cavity region. Okay, this you should keep it in mind. Now, crucible and its charging. So, this is the crucible which I have already told you. Here you see this crucible have a envelope which is made of steel shell. So, just with this steel shell, there is used a layer of refractory types of material. This refractory types of material is generally made up from magnesia. This magnesia, generally this is called liner. That means with this steel shell there is used a liner. This liner generally used because it is a refractory types of material for its heat resistance purpose. Okay. Now, this crucible and its charging, here I am explaining little bit in detail. So, it is a conical shape container vessel. It is filled with reduced amount of thermit mixture. Okay. For here one thing you should keep it in mind, what should be the proportion of thermit mixture required. So, it depends on how much amount of wax we have used for making the wax pattern, because wax pattern is the shape which we actually have to make over this region. So, it depends on that. So, you should always keep it in mind, for if you use 1 kg of wax in this pattern region, then we have to have a thermit mixture which is around 12 to 14 kg. That means we can say wax to a thermit mixture ratio should be 1:12 to 14. So, the outside shell of the vessel, which I have already told you, is made of from sheet steel. This I am showing here. Okay. The bottom of the vessel, there is used a, generally you see a hole, there is used a hole. This hole generally is tapped by a pin. This is called a tapping pin. This hole generally plugged by a pin first. So, this is used for tapping purpose. That means through this hole generally this molten material come out. This you should keep it in mind. So, you see this hole generally created by some what is called magnesia stone and magnesia thimble. This you should keep it in mind. Thimble, this is very well known to you. I am not going in details about the thimble, because thimble is a generally is a cap which is a close end, but what happens which is generally want to protect the finger and push the needle in sewing. Just I am giving you some idea actually what is a thimble types. So, it is a you can say cap with close end. This thimble is a cap with close end. Just this thimble is used generally in this channel region. Now, what happens here, you see everything I have written. First of all, the thimble is inserted in this magnesia stone region. Then this thimble provided a channel through which liquid thermit metal is poured, which I have written here, that every time generally we have to change this thimble for every reaction. So, every time a new thimble is used for each reaction, this you should keep it in mind. The thimble is plugged by suspending the tapping pin. Here you see this is the tapping pin, this thimble and the placing a metal disc above the pin, and above the pin there is used a this is called metal disc, because initially we have to what it is close this magnesia thimble, we have to close this path, correct, because otherwise if we will not close this path, then what happens, this whole mixture will start coming out from this region. So, to close this thing generally there is used a metal disc of that channel. Okay. So, above this metal disc we use some mixture of refractory sand, you see just above this disc we use some refractory sand. Above this refractory sand generally we put the thermit mixture. So, in the thermit mixture generally we create the ignition, and what happens, the chemical reaction is formed, and what happens, material become melted. After that, by tapping this pin, okay, we can bring the molten material out through this channel, and we can pour it through pouring gate, and it go to the desired location where the material is deposited, and finally joining is formed. Ignition the thermit mixture. So, after making all this mixture, that means thimble, above this thimble there is a metal disc, above this disc there is some what it is called refractory sand, above this generally this thermit mixture is used. After that, what is the thing required to do? We have to ignite that thermit mixture. Here one thing you should keep it in mind, that thermit mixture generally lasts up to around 60 seconds. After the ignition is completed, the crucible is tapped to release, what I have already told you, that means a tapping pin is there. So, this crucible is tapped to release the molten material where fusion is taken place, that means where the welding is required to do, there we have to tap this crucible. Okay. That means once this ignition is completed, then crucible is tapped to release molten material. Okay. Now, the crucible work here as a bottom pour ladle, and it is allowed fast removal of the molten material with no danger of slag entering the mold, because a slag basin is already there. So, if some slag is removed from this channel, then after this slag is also deposited in slag basin, as well as due to this molten mixture, what happens, as the aluminum oxide density is less, it also deposited at top side. Okay. Now, the intense heat of this molten metal melt the preheated end of the part to be welded, and complete fusion take place. That means, this molten material once is pour inside this joint, on this molten material will pour inside this joint, then what happens, due to this high temperature, this workpiece and this workpiece edge is highly heated, and what happens here, this melting types of phenomena is taken place, and here the fusion is also taken place. So, a complete fusion welding is taken place in this zone. So, immediately after pouring the material, we should not remove this mold. So, for removing the mold, there is required some time. So, that time generally, so we should remove the mold at around 2 to 4 hours after completion of pouring of molten material. So, it generally depends on this time, depends on what it is called, this time depends on size of the weld region. For a small section, generally this opening of mold time is around 2 to 3 hours. For heavy section, generally it should be more time. Here one thing you should keep it in mind, the longer that mold is left unopened, the better will be the quality of joint. What I am telling, understand? Because what happens, if we suddenly open this thing with less time, then what happens, quality of the welding will not be good, because what happens, there can be rapid cooling types of phenomena. So, there can be hardened of material and all that types of things, chances are there. Okay. So, but what happens, once you keep it for around 2 to 4 hours, then our weld quality will be good. Finally, what is the thing required to do? Finally, we have to remove this mold, then riser and gates, which is cut away by cutting torch, and finally finishing this weld region by grinding operation. This you should keep it in mind, and finally the welding is done. Now, here you see, once they let, this is the what it is called thermit mixer container, and this is one rail, this is another rail. So, here generally this is the what is called mold cavity, you can say that mold around this mold, this is called a flask, around this mold, this is called a flask. So, in this here, why I am showing this figure, in this crucible, first of all we have to do the ignition or chemical reaction. After that, once this molten material is formed, this molten material is poured through this, here is a channel, through this channel to this railway section. So, after that, if some molten material is try to come out from this region, for once this generally to store that coming out molten material, there is used to tray both sides. What is the advantage and limitation of this process, that also we should know. It has lot of advantage, like it is very portable process, and no external power supply is required, because it is a chemical reaction process. Like other welding process, there is required a welding power source. Here no welding power source is required. Here generally whatever the heat we are getting, that is generated by chemical reaction, that is why costly power supply here is not required. It is very cheap process for repairing broken part of large metal structure, especially such as rail lines, then large part of ship. This thermit welding is very popular. One side welding can be done for railway, because one side where there is a scarcity of power supply, there we can utilize this thing very accurately. Now, it has some limitation also, because this welding process is mainly used for ferrous metal parts of heavy section. It is uneconomical when used for welding cheap metal or light part, because for light part it is not economical, because for light part a small section will be there, a small portion is required to join, then for these types of reaction arrangement and other things will not be economical, correct. Then thermit mixture cannot be stored for long time, because thermit mixture cannot be stored due to its safety hazard, and should be used as soon as it prepared. This you should keep it in mind, because whatever the thermit mixture, once it is combined together, that means aluminum ferroxide, this we can store for a long time. So, immediately after mixture we should make the ignition and do the operation or welding operation. Okay. This you should keep it in mind. Here one thing you should keep it in mind, in this thermit welding process, if the thermit welding region will not be properly heated, or if will not remove this moisture part properly in that region, then there is a chance of making the weld porous type. Okay. That is why thermit weld always we have to do by proper precaution. That means every steps, whatever the things I have shown in above slide, we should follow every step very carefully. Now, it has wide application, like it has some very important application, like thermit welding is used cheaply in repair or assembly of large part. It is used generally for repairing of fractured rail. It is used for butt welding of pipe end to end. It is also used for welding of large fractured crankshaft, for welding broken frame or of machine, welding of section of casting, where size prevent their being cast in one piece. That means where the size of cast piece is very large, there generally part cast parts is required to make. After that, okay, we can join together and makes a final cast product. So, for that generally what happens, this cast product also required to join by using thermit welding process. Now, replacing broken teeth in a large gear, generally this thermit welding is widely used. Then end welding of reinforcing bar, which is generally used in huge concrete construction. There if some bar is used, there generally for high or huge construction, there is used some reinforcing bar. Okay. So, to connect this bar, generally there is used thermit welding process. This is the thermit welding hazards. Like what happens in thermit welding, generally there can be develop some ultraviolet ray. So, this thermit reaction release dangerous ultraviolet rays. So, we should be careful from this ultraviolet ray. So, thermit usage is a hazardous due to extremely high temperature produced. That means thermit welding is hazardous because due to extremely high temperature produced and the extreme difficulty in smoothing a reaction once it initiated. So, mixing of water with thermit or pouring water onto burning thermit can cause a steam explosion. That is why it can spraying hot fragment in all direction. So, at that times we should be careful. These are the references which I followed in this lecture. Thank you.